Good morning. Welcome to Algebra 2. Today we're going to actually finish up Section 4, Chapter 5. We have two more quick topics to talk about today, and your assignment then is to finish up all those worksheets. I know we've worked on most of them, but you need to work on worksheet 8.6 and then also do assignment 43 from your book. We'll be reviewing for a quiz tomorrow, and then the quiz will be on Wednesday. Alright, so today we're going to talk about perfect squares and factoring. So the first thing we need to look at, if we're going to really understand about these factoring, we need to remind ourselves about multiplying. Now, a plus 4 squared, we have to be very, very careful with a squared. The common mistake is for someone to think that this is a squared plus 16. But remember, this is really a plus 4 times a plus 4. Which means when we begin to multiply it out, we take a times a plus a times 4 plus a times 4 plus 16. And when you combine the like terms, we get a squared plus 8a plus 16. Okay, so very, very careful. When you multiply out a square, binomial squared, be very careful not to lose that middle term. Okay. Notice that the middle term is 2 times what happens when you multiply the first and the last. That'll be important in a minute. I wanted to point that out so you notice it. Once again, this one is 2x minus 3 squared. So it's 2x minus 3 times 2x minus 3. Once again, first terms, 2 times 2 is 4x squared. The outer terms, 2 times negative 3 is negative 6x. Inner terms, once again, we get a 6x. And the last term's 9. Notice the beginning and the end. The first term and the last terms are perfect squares. 2x times 2x is 4x squared. 3 times 3 is 9. The middle is 2 of these terms. The middle term is 2 of the product of the two terms in the binomial. So it follows a pattern. And that pattern is what we can use as a shortcut, should you notice it, when you're going to factor something that is a perfect square. These two examples are what we call perfect square trinomials. The beginning term and the ending term are both perfect squares, and the middle is twice the product of the two terms in the binomial. First term and last term are both perfect squares, and the middle term is 2 times what you get when you multiply the two terms of the binomial. That's what a perfect square trinomial is. Now, as I said, there is a template, a formula to use for this. If I multiply this one out with just general variables in here, this is a times b times a plus b. So I have a squared plus ab plus ab plus b squared. And what that gives me is a squared plus 2ab plus b squared. So a plus b squared equals this as a general template. A minus b squared is similar to that. A minus b times a minus b. A times a is a squared. A times opposite of b is opposite of ab. Negative b times a is minus ab once again. And the ending part, because it's negative times negative, is once again a positive. The only difference in these two templates is that when you have a minus in your binomial, you get a minus in the middle term of your perfect square trinomial. Okay, so the beginning and the end, like I said when we did the two more concrete examples, the beginning and the end are both perfect squares, and the middle is double what you get when you multiply the first and the last in this part of the binomial. Now what we do is we use this in reverse in order to factor. Alright, so here's our pattern. Okay, we said that a minus b squared equals a squared minus 2ab plus b squared. Now what you can do to check for this to see if you have that pattern is you look at the first term and the last term. Decide whether this is a perfect square and whether this is a perfect square. Now in this case, yes, we do have two perfect squares. This one right here, okay, a is 4 because 4 times 4 is 16, n because n times n is 2, n squared. B is 3. 3 times 3 is 9. Now it only works if this middle part is 2 times what you get when you multiply these. It only works if this middle part is 2 times what you get when you multiply these. So let's check and find out. 2ab is 2 times 4n times 3 which does equal 24n. Okay, now that we found that that's true, we can use this format, this template, in order to factor. Okay, so this is double what these two happen to be when you multiply them. So let's back up this process. A is 4n. B is 3. There was a minus here, so this means it's the negative one. And it's a squared. This is your answer. This is your factored form. This is the answer. Okay, now some of you may have a little bit of difficulty actually seeing that that worked out. If you're just not seeing when you look at it that this is double the product of the square roots of these two, you can factor it based on the method that we had been using before. Let me show you what I mean. Okay. Now, you look for ones, or you look for common factors. There is none. So you can always multiply the 16 times 9. We get 144. So we could always take our 144, and you can find the factors of 144. All right, we're looking for 24 in the middle. We have to have a positive, or we have to have a negative times a negative. Negative 1, negative 144, that doesn't work. Negative 145. Negative 2 would give us negative 72. That doesn't work. Negative 3. Once again, you can use your calculator to divide. That would give you 48. Not there yet. Negative 4. We could take 144 divided by 4. Negative 36. That's still not it. Negative 6. It's 24. Still not quite there. Negative 8. Negative 18. Not quite. Let's try negative 9. Okay. Not quite. Aha, there it is. Need even just a little bit more space for that. Negative 12, negative 12. Now some of you, it may have jumped out of you a little bit sooner than that. There's our negative 24. So 16n squared minus 12n minus 12n plus 9. And once again, we can factor by grouping using that other method we talked about before. Two groups. 4n is the biggest common factor here. 4n minus 3. And 3 is the biggest common factor here. Negative 3 times 4n minus 3. 4n minus 3 is in common. So we have 4n minus 3 times 4n minus 3. And once again, that is the same answer that we just got a minute ago using perfect square trinomials. So either one of those methods, whichever you're more comfortable with, will still give you the same factored form. So just be very careful. Choose whichever one makes the most sense to you. Alright, sometimes, remember, you have to reorder a problem before you can actually solve it. This one we have s squared plus 18s plus 81. This should be an equals. Okay, now what I can notice here is this is a perfect square trinomial. In other words, the first term is squared, the last term is squared, and the middle term is 2 times what you get here. So I'm just going to follow with that pattern. A is s, b is 9, 2ab is 2 times s times 9, which is 18s, which does fit our pattern. That is what we see here. So that means I can use this pattern, a squared plus 2ab plus b squared equals a plus b squared. Okay, so if I'm using this pattern here, my a is s, my b is 9, and it's a plus, so there's a plus there. So here's my factored form of this perfect square trinomial. Alright, so that's perfect square trinomials. Now, just two more new things to look at, and those are the sum and the difference of two cubes. Okay, now there is a factoring formula for these. If you have a cubed plus b cubed, and it is factored out, it comes out to be a plus b times a squared minus ab plus b squared. A cubed minus b cubed turns out to be a minus b times a squared plus ab plus b squared. So what we need to take a look at here is how we can use this to help factor. Now, it only works if you have a cube in this position and you have a cube in this position. A perfect cube is when you have a number times itself 3 times. So first thing you need to do is find out, do I have a difference of 2 cubes, or do I have a sum of 2 cubes? This is x cubed. That's easy. X was cubed. 27, you need to think it through a little bit and figure out what times itself gives you that perfect number. Let's look at some examples. For example, 2 cubed is 2 times 2 times 2, that's 8. You should make sure that you start knowing some of these common ones. 3 cubed, 3 times 3 times 3 is 27. 4 cubed, 4 times 4 times 4 is 64. 5 cubed, 5 times 5 times 5 is 125. So these are some very common cubes. You should keep them in your notes. Keep a little list on the side so that you can recognize them. Okay, or you can go into the math section of your calculator and look for the little cube root sign, which is this, and you can use that to find your cube roots. Okay, but knowing the common ones is going to be the most helpful for you because you can just recognize them. So this is actually the difference of 2 cubes. 3x is cubed and 3 is cubed. So a in our formula, in our template, is x, and b in our template is 3. X cubed and 3 cubed. So what you do is you plug in the a and b into the formula. Here's a, which is x, minus b, which is 3, x minus 3, times x squared plus x times 3, 3x, plus 3 squared. And once you have done that, this is your answer. There's nothing more to it. Recognizing that you have a difference of 2 cubes or the sum of 2 cubes is the whole battle. And once you have that, you put it into the formula and you use it. Make sure that you have these formulas in your notes so that you can use them. They're not as easy to memorize. You don't have to memorize them, but they have to be in your notes. Okay. Let's look at another couple of examples. y cubed and 8. You need to ask yourself, what are the two things that are cubed? This part's easy, it's y. This one, 2 times 2 times 2. So a is y, b is 2. Y cubed and 2 cubed. So it is the sum of two cubes. So we're going to use this formula. And this is our sum of two cubes formula. And then once again you plug in. Y is going to go in everywhere you see an A. And 2 is going to go in everywhere you see a B. Y plus 2 times y squared minus 2y plus 2 squared, which is 4. And the whole factoring is done right there at that point. There is your answer. Okay. Another example. 27x cubed minus 8. This one is a difference of two cubes. It just happens to have a little bit more to it. Instead of just a plain number here, you've got a number and a variable, so you have 3 times 3 times 3 times x times x times x. So your whole thing that's cubed here is 3x. Your whole thing that's cubed here is 2. And it's a difference of two cubes. So you use the difference of two cubes formula. It's very similar to this, but notice there's a couple of pluses and minuses that have been switched. So everywhere you see an A here, you put in a 3x. Everywhere you see a B here, you put in a 2. So we end up with 3x for this A minus, this is a mistake, this should be a what? It should be a 2, right? We need to replace that B with the number. 3x minus 2 minus times 9x squared, that's 3x times 3x, plus 6x, 2 times 3x, plus 4, which is 2 times 2. So these variables all get replaced with a number so that you have the factored form of the difference of two cubes. Okay? It's strictly by formula. Once you've done that, there's nothing more to do. There's no more common factors, nothing. It's done. Okay. Here's one more. Don't forget that you should always look to see if there's a common factor before you start. Here we know that they're both ending in even numbers, so they have to both be divisible by 2. So we bring out a 2 here. This is 2 times 64x cubed, 2 times 27. Once you do that, then you begin to factor this one. Once you bring out your common factor, then you begin to factor this one. And we do notice it's a sum of two perfect cubes. This one's 4 times 4 times 4, 4x. This one's 27, 3 times 3 times 3. So A is 4x, B is 3. Here's our sum of two cubes formula. So you're going to replace all the A's with 4x's and all the B's with 3's. So 2 times A, 4x, plus B, 3, times A squared, 4x times 4x, 16x squared, minus 4x times 3, 4 times 3, 12x, plus B squared, which is 9. Okay, so always look for those common factors first and then use your process. Alright, I just have two more examples I want to show you. These are not new, but you have to make sure that you follow things through. These next two will be very good for you to make yourself able to do for your quiz that's coming up on Wednesday. So let's take a look at these. If I have x to the fourth minus 81, there's nothing in common. However, this is really a difference of two squareds. This is really x squared minus 9 squared. And if you remember from the other day, that means that this equals x squared plus 3, plus 9, and x squared minus 9. This part is finished because this part is a sum of two squares. That part's done. But this second factor is actually its own difference of two squares. So let's take a look at that. This one is x squared minus 3 squared. So this gives us an x plus 3 and x minus 3. Now this one's done. Alright, before you move on, try this one on your own. Note it's very, very similar to what we saw here. So pause it right now, try this one, and then turn it back on so that you can watch and listen. Alright, so x fourth is really x squared minus 4 squared. So that gives you x squared plus 4 and x squared minus 4. This part is finished. There's nothing else you can do with a sum of two squares. But this part can be broken down into x plus 2 and x minus 2. Alright, so that is it for today. Remember that you're responsible for completing worksheet 8.6 and then going on and doing assignment 43 to prepare yourself for a quiz all on factoring on Wednesday. Have a very blessed day.